Okay. Vertical angles are equal. So if this 117 down here, then I have 117 up here. Volunteer. Raise your hand and talk me through another one. All right, fine. Let's see. Let me get some of these people I rarely call on. Flavon. I know, Jet. You're always first, and you know you're first in my heart. Flavon. Go ahead, Flavon. Don't mind the haters.
Yeah.
Okay, you heard that right. For the referral later. All right. We got it. We got proof. All right, go ahead, Flavon. Okay. He's saying the other angle at B?
No, yeah. It should be 23 at D. Right?
At D?
Yeah.
Okay. So, are you talking Z angles, vertical angles, or subtracting from 180 tool?
Z angle.
Okay. He's using his Z angles. Okay. Now I'm going to use my highlighter to help you see what Flavon sees. He's using the Z angle tool. Flavon is saying he's looking at the 23. All right. So everybody, focus your eyes on the 23. Now, draw a Z with me. Like trace it on your own paper, guys. He refuses. He's so cute. Okay? See this? Can you see this? Here's my Z. Can you see this yellowness happening?
Not really.
Right.
I can see it.
Oh, I failed. Okay.
I can see it, but I can't see it.
Okay. All right. Can you see the Z that I'm trying to draw here? Okay. So, looking for your Z angles like we were playing with here, the two corners of the Z should be congruent. So that's why Flavon said, if this is 23 up here, then this will be 23 degrees down here. Okay, he used his Z angles. Did I lose anybody just then? Are we good?
Wait, what did you say? 23?
Do you understand where the 23 got here from?
Yeah.
Okay. All right. Next volunteer. Raise your hand and tell me how to find something else. Or I talked to Matt earlier, so let me get, is it, I want to say, I'm going to say this, Jack, I bet. See, I wasn't even looking. That's not even the right class period. I'm learning. Okay. Let's see. Okay. Another Z angle that we could use. I hear Jack saying. Let me erase the first Z so we can focus on the new Z. All right, there's another Z that's like this. Okay? I mean, it's more of an N, but, you know, I'm going to always call it a Z. Okay? Can everybody see this Z angle that I just drew in yellow? Okay? So Jack is saying, look, guys, if this is 80, look at the 80. Then there should be another 80 in the other corner of the Z down here. So won't that be 80? That's what Jack is saying. All right? Does that make sense, Haley?
Yeah.
Okay. Lisa, do you have another one? Or was that the same one you were going to do? Okay. Do you have another one, Matt, or was that the one you were going to do? All right, new volunteer. Ashley.
You can put 40 in A.
Tell me where you're getting 40 from.
You add, or you subtract 117 and 23.
Okay. We're using that third tool. The one where everything adds up to 180. So now looking in the top triangle, we have 117 and 23. We have two of the angles, so we should be able to have the third one. What's happening? I don't know what happened.
So there's like 30 angles.
40.
So basically, if we go 180 minus 117 minus 23, subtract these two angles, and Ashley said 40. Okay, so that leaves 40. So that's why this angle right here should be 40. Did you understand that?
Yeah.
No. Okay. Check this out. Jill, help me find something else.
Would C be 42?
Yes. Okay, look at this angle down here at C. You could think of this one by two different tools. Or did you look at this as a Z angle situation, or did you subtract from 180 again? Okay. I mean, the bottom triangle is identical to the top triangle. So if we had if we had 117 and 23, the other one is 40. We have 117 and 23, obviously the other one is going to be 40. Okay? You could do a Z angle and see it that way as well. But subtracting from 180 again gives us 40. Are there any other angles we could find, or are we stuck? Are we done?
No.
Have we found everything so is there no way to find these, the missing, there's one more angle missing. Is there no way to find those? Okay. There's another tool that I neglected to mention. There's a fourth tool. So that's what we're missing. Here's the fourth tool. And you guys already know this, but you don't know that you know it, so here we go. Say if I have a straight line. My question to you is going to be, how many degrees are in a straight line?
180.
180.
Okay? Raise your hand if you knew that a straight line formed a 180 degree angle. Who already knew that? Who knew that a straight line was 180 degrees? Okay? Put your hand down. All right, so that was most of you. Especially people that didn't raise your hand just now. How many degrees are in a full circle?
360.
All right? Does everybody understand that a full circle is 360 degrees? So if I went, come on, draw a pen. All right. If I went all the way around, that would be 360 degrees. So a straight line is just halfway. Half of 360 is 180. So a straight line is always 180 degrees. Because of that, because a straight line is always 180, if I take a straight line and split it into two parts, like this. So here's my straight line, and bam! I split it into two angles. Okay? So, I know, it's amazing how I can draw so straight. Say if I told you that this was 40 degrees, and I left you on your own to figure out the other angle. Would you be lost, or would you be like, no problem, Burton?
No problem, Bird.
Smacking the microphone. What would I do, Jill? I see your hand.
You take 180 and subtract it from 40.
Sure, couldn't I just do 180 minus 40, since they're supposed to add up to 180? There's a word for that. Do you guys remember the word for adding up to 180?
Supplementary.
Supplementary. Okay, let's work on our vocabulary. Supplementary. This is an example of two angles that are supplementary. Anyway, so this should turn out to be, for example, 140. Okay? So keep that in mind. That's another tool in our toolkit. If anything that makes a straight line, those two angles should be supplementary. So, now, what does that have to do with this problem? Let me see if I can show you. Here's my straight line that I'm looking at, DB. I mean, I could have put it the other way too. Let me make it a little bigger. And let's make it, say, orange.
Purple.
Black.
Purple. Yellow. Orange.
Okay, I made it purple. Okay, look at that as my straight line. Now, I'm going to split that into two angles. So we know that a straight line is 180 degrees across. So if I take that and I split it into two angles, they should be supplementary. So for, what am I doing, Burton? Techno fail. Okay? Say if I split it sort of like this. Okay, do you see all that purple? This purple is representing a straight line that I have now divided into two separate angles. They should be supplementary. But can everybody see that on one side of the line, I have 117? Okay? So like over here, this part of the purple line is 117. So Haley, how could I find this part?
Subtract it from 180.
Subtract it from 180. Can everybody do that real quick right now? 180 minus 117 and tell me. 63. Did everybody get 63? So that's another tool in our toolbox, using the straight line being 180, so you can subtract from 180 anytime you make a straight line. So that's 63. Can you immediately know another angle that's going to be 63? The other across from it, that's going to be 63. So now we've got that one. What about the angle up at B, or the angle down here at D? Can somebody raise your hand and tell me how I would find that? Somebody haven't called on yet. Somebody new. I've seen my same 5 people. I've called on Flavon, Jill, Matt, Mariam. Tell me how I could find the missing angle. Subtracting from 180 again. At this point, we have 2 angles in the triangle. We could subtract from 180 to find the last angle. Can you do that? Have you done that? What's the answer? 37. Can we all agree that this final angle is going to be 37 by subtracting from 180? Okay, did I lose anybody? So obviously, what's going to be this other angle down here at D? Right, same situation. So another 37. So by using all of our tools, we have been able to find every single missing angle. Only given 3 angles at first, we were able to find every angle in this picture. So it's like a puzzle. All of this stuff is like a puzzle. So as we look back to the questions that we were actually asked, we should be able to, some of them will be right on this picture, some of them will have to add up a couple numbers. Okay? So, for example, I guess I should go in order. So look at number 12. I want to find angle AEB. Now, Haley, when I say angle AEB, I'm emphasizing that E in the middle because that E in the middle tells us the angle that we need to look our eyes at. Okay? So everybody look at this with me. Angle AEB. Let's see which angle we're talking about. I need to get rid of that yellow Z because I might need some more yellow. Okay? So, angle AEB. Okay, that's just this angle right here that I'm drawing in yellow. A, can't really see it very well, B. How many degrees is angle AEB that I just traced?
Well, AEB would be...
That's the 117, okay? Looking at the E as the middle, that's 117. So everybody should put 117 for number 12. Okay, number 13, we're supposed to find angle BAE. BAE. Okay? Talk to me. Jill.
Oh, wouldn't it be 120 degrees?
Let's see. BA, wait a minute. What angle are we finding?
Finding angles.
Okay. Well, we have to be real specific. Watch how we trace it. Because there are 3 angles at angle A. So I have to be careful.
40.
Right. Okay? So that's why we had to use our 3 letters, because we're talking about angle BAE goes from here to here to here. All right? Angle BAE is the yellow angle that I just drew. So that's 40. It's the 40. So for number 13, everybody should put 40. All right, please stop me if I lose you, you guys. Don't let me keep going. I'm just not a keep going kind of a guy. I hope you know that about me. I will stop this train. I will pull this car over. All right. Yeah, don't make me come back there. So, AED. Look at angle AED. All right, see if you can find it before I do. Blurt it out, you guys. Just blurt it out. Can everybody see that's going to be 63?
No, I don't understand.
Okay. Jet, watch the yellow. Watch the yellow, brother.
Oh, no. I see.
Angle AED goes from A to E to D.
No. I thought it was 60.
Wait, so I hear you saying that you understand now.
No. I understand that, but that is confusing.
So 63. Angle AED is the yellow angle. That's clearly 63.
Never mind.
Heard that.
I just can't get it.
All right, try to get ahead of me, you guys, and stay ahead of me until number 19. So number 15, angle ECB. You know what? This purple is bugging me. Let me just stop and get rid of it. Okay. Angle ECB would be this angle right here. ECB. That yellow angle is how many degrees? That's 80. So everybody put 80 for number 15. Okay, number 16. Angle BAD. BAD. Okay, BAD. Okay, can everybody see that angle BAD is a big angle? It's not one of the ones that we have an actual number written for. Angle BAD is the combination of two angles. What two angles am I going to have to add, Tyler? What am I adding to make this yellow angle? Just give me the two numbers. Right, to get the yellow angle, BAD, what two angles, Tyler, am I going to have to add? 80 and 40. So obviously, what's 80 plus 40? 120. Okay, so angle BAD, everybody should put 120. Okay, if I lose you, please stop me immediately. Do not wait for like 5 questions later. Angle DCE. Okay, DCE is this, from D to C to E. That yellow angle is angle DCE. And I hear you saying 40. That's going to be 40. So everybody write down 40 for that one, for number 17. Okay, number 18, ADC, angle ADC. Okay, ADC goes from A to D to C. That's another combo one. Daniel, what two numbers will I have to add to get this one, brother? 23 and 37. What is that? Anybody blurt it out?
60.
That'll be 60. 23 and 37.
How did you get that?
Okay. Do you understand why I'm doing the yellow angle, first of all?
Yeah.
What?
Wait, which one are you on?
We are on number
19.
18.
I thought you were on
Okay. So number 18 was 60. And finally, number 19. Angle DCB. Jordan, that's 2. We don't say shut up in here. Angle DCB. Okay, DCB is another combo angle. Okay, Tiger. Well, actually, yeah, go ahead. Tiger, tell me which two numbers I'm going to have to add to make this angle. 40 and 80. What's that going to be? That's 120 again. So number 19 should be 120. Okay, that's how you should have done your warm-up. Any questions about that? Do you understand it now that I break it down for you? Does that make sense, Andrew? Okay. All right, now let's go on with the lesson. Okay, first of all, a quick review. I guess there's technically one more problem still in part of your warm-up. We're reviewing what converse means. How do we go about finding the converse?
I am having a great day
Right. Well, tell me in general first. How do we build a converse just like in general? What do we do? Is this one where we negate them or?
We change the if-then statement so that goes if.
Right. We take that hypothesis and conclusion and we reverse them. We basically write the whole thing backwards. That's converse. So Jill is saying that this one would be, if I'm having a great time, then I'm in math class. That would be the converse. So I just wanted to get that back in the front of your brain. And here's why. Yesterday, I taught you the definition of a parallelogram, and then I taught you 4 special properties of a parallelogram. Today, we're going to do the converse of all of those properties and find ways that we can prove that some random quadrilateral is a parallelogram. So first, I need you to tell me, can anyone tell me what the definition of a parallelogram is? Only Jet? Not even Jet. Nobody can tell me what the definition of a parallelogram is? Okay, I haven't heard from Mason yet.
A quadrilateral where both pairs are parallel.
Yes. Okay, and look, between now and test time, you guys are going to have to be able to, if I ask you the definition of one of our many shapes, you should be able to just rattle it off. Okay, so just mentally prepare yourself to go into memorization mode. But the definition of parallelogram is right there in the name. Parallelogram. A parallelogram is the one where opposite sides are parallel. That's the definition. Now, that's what a parallelogram is. Now let's talk about the 4 special properties I taught you. Can anyone remember, or if you want to look back at your notes, I'll accept that as well. But can somebody tell me one special property of a parallelogram? Lisa, go.
If a quadrilateral is a parallelogram, then its opposite sides are congruent.
Okay, so one special property of a parallelogram is opposite sides. And I'm going to go ahead and use the symbol. This is the symbol for congruent. So when you see this symbol, know that that means congruent. It's an equal sign with a tilde over it. Alright, I'm hoping you're not seeing this for the first time and you know what a congruent symbol is already. Okay, somebody tell me another property of a parallelogram that I taught you. Bryant, haven't talked to Bryant today.
Consecutive angles are supplementary.
Okay. Consecutive angles, meaning angles right next to each other. Consecutive angles are supplementary. Okay? So, angles that are right next to each other add up to 180 degrees. It means they add up to 180 degrees. Chase. And then, so we had opposite sides are congruent, but also opposite angles are congruent. Opposite angles are congruent. And then there is one more. Ward?
Is it that all interior angles have 360?
That's a fact, but that's not special to a parallelogram. That's true for any quadrilateral. Can you give me the other special parallelogram property?
If a quadrilateral is a parallelogram, then its diagonals bisect each other.
Okay, the diagonals will bisect each other. In other words, these diagonals will cut each other in half. So this is the 4th property I gave you. The diagonals bisect each other. Okay, those are the 4 properties. Now, we're going to do the converse of each of those properties. So basically, these properties are saying, if it's a parallelogram, then opposite sides are congruent. That's the first one. The converse of that would be, if the opposite sides are congruent, then it's a parallelogram. So can you hear in your mind how we could maybe use these converses to prove that something's a parallelogram? If the opposite angles are congruent, then it's a parallelogram. That's the converse. We could prove something's a parallelogram. If consecutive angles are supplementary, actually that one's not going to work. Only 3 of these are going to work as converses. Number 3 is not reversible. Okay, number 3, the converse doesn't work. But the other 3 will work as converses. If I have opposite sides congruent, guess what? It's going to be a parallelogram. If I have opposite angles congruent, that proves it's a parallelogram. If I have something where the diagonals bisect, that proves it's a parallelogram. So those are 3 ways to prove something's a parallelogram so far. Supplementary angles, that won't prove it for me, but there is a 4th one I'm going to give you. So basically, I've told you these things right here. So Theorem 5.22, if opposite sides are congruent, it's a parallelogram. We just said that. If opposite angles are congruent, it's a parallelogram. Okay, it's just the converse of the one above it. If the diagonals bisect, it's a parallelogram. So those are all the converses we were talking about. Now this 4th one is new. Okay, this 4th one's not a converse of something else. Try to understand this. If one pair of sides is both parallel and congruent, this is what I'm talking about, you guys. If one pair of sides is both parallel and congruent. Okay, we're talking about ways to prove that something is a parallelogram. So, look, here's my diagram. If I knew opposite angles were congruent, boom, I'd know it was a parallelogram. Opposite sides, it's a parallelogram. If the diagonals cut each other in half, I know it's a parallelogram. But here's this final one that I'm trying to teach you. If I knew that, say, this pair of sides was parallel, and that's how you show that something's parallel, little arrows. Now, if I have that same pair that's also congruent, and I can show congruent by putting little marks on it, like this. If I had this information, I'm guaranteed that this is a parallelogram. It has to be the same pair that's both parallel and congruent. Look, what if it was one of each? What if I, let's see, let me draw another one. Here's another parallelogram. What if I told you that this pair of sides was parallel and this pair of sides was congruent? Would this be enough information for me to know that this is definitely a parallelogram? No, this would not be enough information because it has to be the same pair that's parallel and congruent at the same time. It can't be one of each. It has to be the same pair twice, like I have in this picture. This one, yes, that's definitely a parallelogram. This one, no.
Wait, can I see the first one again? Why? How is it different?
Because it's the same pair of sides. See how it's the top and bottom that's parallel, and it's also the top and bottom that are congruent. But on this one, it's the top and bottom that are congruent, but it's the sides that are parallel. It's got to be the same ones both times. It can't be the top and bottom and then the sides. It has to be the same. You still look confused. These yellow ones I just drew, those are the ones that are parallel. And they're also the ones that are congruent. It's the same both times, okay? But for this one down here, these are the ones that are congruent, but these are the ones that are parallel. They're not the same ones twice, okay? It had to be the same pair twice. Jet, thank you. Look at this example A. Do I have enough information to know that this is a parallelogram?
No.
Yes.
Well, considering one thing, before I answer the question, can I find the missing angle right here?
Yes.
How many degrees are in every quadrilateral?
360.
There's always going to be 360 degrees. So I could find the missing angle by subtracting these three angles from 360. So somebody do that. Everybody do that. Everybody go 360 minus 67 minus 113 minus 113. Tell me what you get. 67. Okay? So we come out with 67. Now tell me why we know for a fact that this is a parallelogram.
Angles are
Because I hear three of you, this is really not working. I hear three of you saying, because I have both pairs of opposite angles congruent. If both pairs of opposite angles are congruent, then I know it is a parallelogram. So I would say yes, and if I asked you to explain, I'd say because both pairs of opposite angles are congruent. Look at number 1. Okay, so this one I'm not asking you why. Okay, which theorem can be used to show that the quadrilateral is a parallelogram? Why do I know that number 1 is a parallelogram?
Because it's opposite angles.
Is it because opposite sides are congruent? Is that the one? Is it because opposite angles are congruent?
Opposite sides.
It's the one about diagonals. Now what is it? Can you read it? What is that one about diagonals? The diagonals bisect. See how they're cutting each other in half? 6 and 6, 9 and 9. They're cutting each other in half. So yes, it's because the diagonals bisect each other. Okay, that's why. Number 2 sort of strikes me as a... No, number 2 is okay. Why do we know that number 2 is a parallelogram?
opposite sides are good.
Because opposite sides are congruent. Okay, we have the marks for the top and bottom, and we have the 26s for the sides. Opposite sides are congruent. Look at number 3. Why do I know that number 3 is a parallelogram? Because opposite angles are congruent. That's not what you were saying. Okay, now number 4 is the new one that was a little bit hard to understand, but why do I know that number 4 is a parallelogram? Okay, you basically have to say this, because one pair of sides, write this down, this is a tricky one for you guys to understand, because one pair of sides is both congruent and parallel. See what I did there? That's the symbol for parallel. Those two slanty lines, two little parallel lines. So that's this one. One pair of sides is both congruent and parallel. Okay?
Wait,
Waiting.
so I don't get like what you said.
Okay, look at number 5. Why do we know that this quadrilateral is a parallelogram? Well, look at these numbers, 3x and 3x. So we know that these are congruent, 5x and 5x. So these are congruent. So these are diagonal. So this is the one that we can prove is a parallelogram because diagonals bisect each other. Okay. Now look at number 6. So number 6 is a different kind of question. For what value of x is the quadrilateral a parallelogram? So if you assume for a minute that the quadrilateral is a parallelogram, well, we have these sides parallel, so these sides would also have to be congruent to be a parallelogram. So, of course, that means that 5x plus 2 would have to equal 5x plus 2. I mean, 4 times x plus 2. So 5x plus 2 must equal 4 times x plus 2 if this is going to be a parallelogram. So a little distributive property. So that gives you 5x plus 2 equals 4x plus 8. I would subtract 4x from both sides. So that gives us x plus 2 equals 8. If we subtract 2 from both sides, that gives us x equals 6. So that is the value of x for which this would be a parallelogram. Just you're setting them equal to each other. Okay, so that's number 6. Now, decide whether you are given enough information to determine that the quadrilateral is a parallelogram. So we're just going to say yes or no. Let's see. Say if we're given that E is the midpoint of AC and BD. Well, if E is the midpoint, that would make these congruent and these congruent. If E is the midpoint. So there, that means the diagonals would bisect. So that's one of the ways that we can prove it. So that's a yes. Okay. What about this one? If we were given that angle ABC, okay, focus on the middle letter, B. So angle ABC, that's this angle right here, is congruent to ADC. ADC, that's this angle right here. Wait, I skipped 2 problems. I am so sorry. Okay, I'm back up here. Oh, I saw the ABC. Okay, let me try again. Angle ABC, okay, that's this one, plus angle BCD is this angle right here. Now, they're not saying they're congruent. The problem says they are supplementary. They add up to 180. So these are consecutive angles that are being supplementary. And looking back, yesterday we learned that in a parallelogram, consecutive angles are supplementary. But guess what? This one is not reversible. In other words, just because consecutive angles are supplementary does not mean that you are a parallelogram. So supplementary is not one of the ways that you can prove that something is a parallelogram. So if that comes up, you're going to say no, that will not prove it. So let's see. Next one. AB is parallel to DC. So let's start over. So AB is parallel to DC. So here's AB. And we show parallel with arrows. So these are parallel. And BC is parallel to DA. No, not parallel. BC is congruent to DA. So there's BC being congruent to DA. Is this enough information to know that this is a parallelogram? No, is not. Okay, there is a theorem that involves having a pair of sides that's congruent and a pair of sides that's parallel. It's the reason why number 4 is a parallelogram. But the key is it has to be the same pair of sides. Number 4 is definitely a parallelogram, but it's because this pair of sides that I just colored yellow is parallel, you see the arrows, and it's congruent, you see the 15s. But it has to be the yellow sides both times You can't have the sides being parallel and then the top and bottom being congruent. That would not prove that you are a parallelogram. Okay, so this would be a no. Alright. Okay, what about these? Angle ABC is congruent to ADC. Okay, ABC is this one again. ADC is this one. And BAD, okay, BAD is congruent to BCD. BCD. Okay, here's a picture of this one. Is this enough information to prove that this is a parallelogram? Oh, yes, it is. Opposite angles are congruent. That's one of the ways we prove that something is a parallelogram. Okay. Now, so these last couple ones involve congruent triangles. Triangle ABE. Okay, here's triangle ABE. Is congruent to triangle DCE. Okay, so here's triangle DCE. Now, we have to be really careful with the way these letters match up. Look at these segments. Segment AB would be congruent to DC. So you can see from the order of the letters. So AB, okay, would be congruent to DC. Now, similarly, we can see that segment BE would be congruent to segment CE. So BE and CE are in the same places. So BE and CE would be like right here. And then that leaves AE to be congruent to ED. Okay, so these are the congruencies I would get from this triangle congruence. So is this enough to prove that the two triangles, that the shape is a parallelogram? Well, the only aspect of this that has a chance, because we don't have any angles for opposite angles. As far as opposite sides, we only have one pair of opposite sides of this quadrilateral. We don't have any parallel lines, so we can't use the one about the same pair of sides being both congruent and parallel. So that leaves the one about diagonals, bisecting. Now if we look very carefully, these diagonals are not necessarily bisecting, because, for example, AC is a diagonal. But if you look at point E as the potential midpoint, the left side of it has 3 marks. The right side of it has 2 marks. So these sides are not congruent. So that means E does not need to be the midpoint. So that means it's not bisecting. Same thing looking the other way. We have 2 marks and 3 marks. Those aren't the same. So E is not the midpoint. So the diagonals are not bisecting. And that was the only one that had a chance. So this is going to be a no. Now compare that to the last question here, which it involves really the same two triangles. ABE, of course, is a red triangle. Now instead of saying DCE, they just changed the letters to CDE. Okay, CDE. But what that changes is which parts are congruent. So look at the matching now. AB is now congruent to CD. Okay, well that's the same as before, AB and CD. But here's where it changes. Look at the next congruency. Okay, BE is congruent to DE. So BE is congruent to DE. See what's changing here? Now these congruencies are on the same diagonal. So looking at diagonal BD, E is now the midpoint of that diagonal because these are the same. And that leaves AE, 1, 2, 3, to be congruent to EC, 1, 2, 3. So again, E is the midpoint of this diagonal as well. So with these markings, we can see the diagonals bisect, which is enough information to prove that it is a parallelogram. So that is a yes. So you have to be really careful with the triangle congruences. And that is the end of the lesson.